The importance of Ketelosaur. Ketelosaurs were a group of primitive and now extinct reptilians which first appeared on Earth 310 million years ago. Although relatively small, only reaching a maximum of 1 foot in length, Ketelosaurs became the first vertebrates to fully adapt to terrestrial life and would consequently go on to be one of the most important species to ever exist. One way in which Ketelosaurs helped to shape terrestrial life in their time, and even in ours today, is the way in which they reproduced. Award-winning science writer Ron Redfern writes about Ketelosaurs and the oat egg. Quote, "During their reproductive processes, Ketelosaurs spawned embryos enclosed in nearly waterproof casings that were resistant to desiccation but permeable to oxygen." End quote. Remember, this adaptation provided Ketelosaur and its ancestors the ability to thrive in a myriad of environments, both wet and dry, when previously only wet environments were favorable. Redfern goes on to say, quote, "The success of the amniotic system of reproduction changed the main thrust of evolution completely and exponentially." End quote. An amniotic egg has 3 membranes, which are actual outgrowths of the embryo itself. Each shell has a purpose. The outermost for protection, the middle stores waste, and the innermost houses the embryo. Ketelosaur, now able to thrive in a myriad of environments, soon began to spread. Now migration was made easy in the time of Ketelosaur because during the Permian age the continents were all still connected, forming the supercontinent Pangaea. Not only was Pangaea a supercontinent, but it was also relatively flat. No mountains or large obstructions for Ketelosaur or other creatures alike. Not far into Ketelosaur's tenure into the Permian, evolutionary divergence began to appear within the species. 2 main groups dominated, the Pelycosaurs and the Therapsid. The Pelycosaur, a direct descendant of Ketelosaur, made tremendous evolutionary strides. 2 openings in the skull made Pelycosaur's head lighter, and eventually gave way to jaw and tooth development. Consequently, a higher head position was adopted. Next, Pelycosaur's previously splayed legs developed into the kind of legs capable of directly supporting weight from above. This adaptation proved much more efficient than the former positioning, which diverted stress inward. As you can imagine, these developments allowed Pelycosaur to move quicker, evade predators, and find his own prey with ease. Ketelosaur's descendants progressed into and through to the late Pangaean. These reptilians thrived on the land and sea and even in the air. After the Permian extinction occurred some 200 million years ago, Earth's first mammals emerged. These mammals evolved from the evolutionary tree of Therapsid. Today, the most direct descendants of Ketelosaur are heavily armored reptiles like amphibious and terrestrial tortoises. Ketelosaur's enduring legacy is certainly evident in many of these creatures' primitive attributes, specifically the modern turtle's heavy shell, slow movement, and sprawling gait. Finally, Redfern notes, quote, "It is a fact of life that all cold-blooded and warm-blooded reptiles and birds and mammals, monitory, marsupial, and placental alike, are all descended from Ketelosaur." End quote. What an amazing and important animal Ketelosaur is proven to be.